AAG, Unit 7, Part 2 quiz. So we're going to review for our quiz on solving word problems using trig. So we have our SOHCAHTOA acronym, right, which is a 9-letter acronym that helps us to remember 3 of the basic trig functions, right, sine, cosine, and tangent. Now for our quiz, and just really for moving forward in the next couple years of math, you're going to need to know how to use these 3 equations, all right? You're going to need to know, when to pick each one, all right? So the sine compares the opposite to the hypotenuse, cosine compares the adjacent to the hypotenuse, and tangent compares the opposite to adjacent. Now, for our quiz, there's really 4 components that we're looking for. So the first is, students should be able to read a word problem and then draw and label a diagram. Putting your labels and your lengths and your angles in the right spots is critical, right? It's critical because if you don't have the right diagram, then you're going to be in trouble for the next step. Students should then use their diagram to choose the appropriate trig equation based on their drawing to find the missing side or angle. So basically, once you have your diagram, you're going to need to choose either sine or cosine or tangent. For example, if the word problem compares the opposite to the adjacent, then which one are you going to pick? Right, we're going to go with tangent, okay? Let's see, third item on the list says students should write and solve their equation and show their 3 steps as modeled during class. So once you have picked your trig equation, then you're going to substitute your values and show your 3 steps in solving. Finally, that brings us to the last one. Students should round answers to the nearest hundredth and properly use their calculators. We're going to make sure that they are set to degrees. We're going to talk about solving for side lengths and angle measures. So in this case, I wanted to go back a ways, to some things that you learned in your past. I want to talk about an input-output machine because it might put some things into perspective here. So, for example, if we just, go back to, I don't know, middle school, elementary school, let's say the input-out machine's job was to execute x plus 4. What would we input? Well, think about it. I would input some type of value for x. So if I just picked randomly x equals 10, well, then 10 would go in the machine, it would be replaced for x, and the output would be 14. All right, so something goes in, something comes out. So what I want to do is apply this to trigonometry. I want to apply this to what we've been doing lately. So what I want to do here is I want to have the machine think about applying the sine function, right? So now whenever we grab our calculators and as soon as we type in sine, it's going to ask for something, okay? And that something is going to be the degrees. It's going to be the angle, okay? Or theta, right? That's what we've been using. So if I want the machine to execute the sine of theta, well, guys, the angle goes in and the ratio comes out, all right? So what do we want to do here? I want to try to use something familiar, right? So let's use a 30, 60, 90 right triangle. Okay, so if I'm still using sine, let's go try to use this example above, triangle ABC. So let's pick one of the angles. I'm going to choose angle B, or 30 degrees, okay? So check it out. 30 is going to be the input. 30 goes in and replaces theta. So we would take the sine of 30 degrees. Now, if you take your calculator out, it'll give you 0.5, but in this case, let's use this particular triangle. Sine compares opposite over hypotenuse. So the ratio of that will come out of this input-output machine. So looking from the reference angle 30 degrees, 8 is opposite, 16 is the hypotenuse. So we would get 8/16 or 1/2 or 0.5. All right, guys, so straightforward sine, cosine, and tangent. The input that goes in is going to be your degrees or your theta, and what comes out is your ratio. So just to kind of put it in perspective, the degrees or theta goes in, the ratio comes out. Okay, the comparison of the 2 sides, the fraction. All right, so now let's try to apply this to another angle, right? Let's just say, and I'm going to choose a different trig function. Let's use tangent of theta, okay? So now if I choose tangent of just randomly picking, tangent of angle A, tangent of 60 degrees. Well, think about it. 60 is your input, 60 is your theta, and now we're going to take the tangent of 60. Degrees goes in, ratio comes out. So here's 60 degrees, tangent is opposite, which is 8, over radical 3, right? Opposite over adjacent. And then the adjacent side is going to be 8. Now the 8s will divide out. We will be left with radical 3. Or if you take your calculator, ladies and gentlemen, what do you get if you type in the tangent of 60 or if you type in the square root of 3? And that's right, you're going to get approximately 1.73 every single time. Okay, so now let's go and take a look at this other triangle because it's not a special right triangle, but it's actually going to ask us to go backwards. All right, now this is really why I wanted to show you this diagram. So in this case, we have all three sides, but we do not know the angle measures. So what I'd like to do is work backwards. The calculator is now going to use what type of function, right, guys? Or what I'm basically asking is, how do we undo sine? How do we undo cosine? Or how do we undo tangent? We're going to use what? That's right, we're going to use an inverse function. We're going to go backwards. All right, it's backwards or inverted, hence inverse. So what I want to do is I want to choose theta, all right, to be, we want that to be our output. We want to reverse this process. So instead of theta going in, theta is going to come out. But let's reverse the process from before. So now we're going to have to input the ratio, all right, or the fraction or the decimal. So what we can do here is we can actually choose, all right, sine, cosine, or tangent. I'm going to choose cosine, okay? So now what I want to do is I want to undo the effect of cosine on the ratio, on the fraction. We're going backwards here. So how do we undo cosine? We're going to use, that's right, inverse cosine. So now I want to use the inverse cosine of, I'm trying to write that really small there, but that says the inverse cosine of the ratio, of the fraction, adjacent over hypotenuse. So that means the ratio goes in, inverse cosine will reverse the process, and it will spit out our angle measure. So let's go up top here, and let's say we're looking from D. You know, sometimes I put a little stick figure there to show your frame of reference. Cosine, adjacent over hypotenuse. So adjacent is going to be 4, hypotenuse is going to be 5. So 4/5 goes in, or 0.8, 0.8 would work as well. So now what I'd like you to do is please go type into your calculator the inverse cosine of 4/5. That's right, we're going to get about 36.87 degrees. All right, ladies and gentlemen, so I wanted to use this illustration to show that normally the theta goes in, the angle goes in, and the rate or ratio comes out, but reversing the process will give us your angle measure. Now let's try an example of what we just talked about. I'd like to try to use an inverse to backtrack and find the measure of an angle. So let's take a look here. A right triangle has side lengths of 5, 12, and 13 meters. Using your trig inverses, find the measures of both acute angles in this triangle. So I've labeled them as x degrees and y degrees. You can use theta. You can use any other variable you'd like. So what I want to do here is this, all right? I have picked one of the angles. As you can see, there's an x next to each of them. So I have the sine of x, cosine of x, and the tangent of x. What I'd like to do first is I want to create the fractions for each. So what is the fraction for this sine of x? Well, since the sine compares opposite over adjacent, we're going to have 5/13. What is the cosine fraction for x degrees? Cosine compares adjacent to hypotenuse. That's going to give us 12/13. And finally, what is our tangent fraction for x degrees? Tangent compares opposite over adjacent, so that's going to give us 5/12. And now we have all three of our fractions for sine of x, cosine of x, and tangent of x. Now, guys, we could solve all three of these using the inverse sine, inverse cosine, inverse tangent, but it's going to give us the same answer. So we don't have to do it 3 different times. So what I'd like to do is I'm just going to use the equation on top. I'm going to use sine, but we could have used either of the other two equations. So here we go. Now, I want to remind you, for your quiz, you're going to be required to show 3 steps in solving your equations. For angle measures, here we go. We have the first one done for us. We wrote our sine equation and have our fraction there. We now need to tell the calculator to work backwards. Guys, how will we undo sine? We're going to use the inverse sine. So what we show is this. Okay, in our previous example with the input-output machine, we were backtracking. So we're going to have to tell the calculator, hey, here's our ratio, here's our fraction. Use the inverse sign to backtrack and undo. Ladies and gentlemen, after typing in your calculator, what is the inverse sign of 5/13? Good. We get approximately 22.62 degrees. Now, they did ask us for both of the acute angles in this triangle. So, I mean, literally what we could do is, if you wanted to, that is x degrees. We could subtract from 180 degrees in the triangle to get y. But just for practice, okay, just for practice, I'm going to solve a trig equation to get the measure of y. All right, y degrees. I'm just going to pick tangent, but we could literally pick any of the other ones we want. So let's see. The tangent of y degrees is going to be what fraction? Well, that's going to be the opposite, which is 12, over the adjacent, which is 5. So now, ladies and gentlemen, how do we undo tangent? We're going to use inverse tangent. Just trying to squeeze this in over here. Inverse tangent of the ratio, of the fraction. And then, ladies and gentlemen, what is the inverse tangent of 12/5? Good. That's going to give us 67.38 degrees. And most importantly, we can check our work here and see if we did this correctly. These two angles, 22.62 and 67.38, should be what type of angles? Right. They should always add up to 90 degrees, which would make them complementary angles. Okay, let's try one more example in which they ask us to find an angle of elevation. So in this case, a ramp is built that leads up to a doorway. Its slope is 1/13. Remember that slope is rise over run. Find the angle that the ramp will make with the horizontal. All right, so after we read the directions, let's remember a few things. Yes, slope describes the steepness of a line, or in this case, the steepness of the ramp. The ramp has a slope of 1/13. So guys, whenever we draw a right triangle like this, and this is true for roofs, for staircases, or even in this case for a ramp, the rise will always be your vertical, and the run will always be your left and right, or your over left and right. So in this case, they tell us the slope is 1/13, so that means I'm going to put a rise of 1 and a run of 13. Now, if we wanted to, we could use the Pythagorean theorem and find the missing side, but we don't need that. Let me show you why. If we want to find the angle measure that the ramp will make with the horizontal, aka the angle of elevation, I'm going to put my theta there. Now, in this case, we're going to now choose which trig function to use. So in this case, ladies and gentlemen, I see 1 straight across. I see 13 down here. Which trig function will we use? All right, so we're going to go ahead and use tangent. Now, for the tangent function, let's go ahead and write our general equation. Tangent of theta, which we don't know, equals opposite over adjacent. Now, if you notice here, guys, this is a commonly used equation in engineering where the tangent of an angle is equal to the slope. All right, but what we're going to worry about is how to undo the effect of tangent. So, guys, how do we undo tangent? We're going to use inverse tangent. Good. So inverse tangent of the ratio or the fraction. The calculator is going to backtrack. It's going to go get the angle for us. What is that angle measure, ladies and gentlemen, to the nearest hundredth? I'm getting about 4.4 or 4.40 degrees. All right, so not very steep, but that makes sense, I think, because we're only rising 1 for every run of 13. Okay, similar example here. So I wanted to use another kind of real-life, real-world application. So we have a hill or a road here that has a 25% grade. In order for engineers to decide the appropriate speed for drivers to safely navigate, we will need to describe what this steepness means. What is the angle of elevation of this hill? So what I'd like to do here is I want to just kind of recreate the triangle that you see in the sign, literally in the sign. Hopefully you notice there's that right triangle that we're working on in this chapter. So a 25% grade, let's think about what that means. That is actually giving you the slope, a 25% grade. So let's think about, first of all, what does 25% mean? Percent means that number out of 100. So in this case, we would have 25 over 100. Now, ladies and gentlemen, after we just took a look at our previous example with the ramp, this is very, very similar. this is going to be your rise, and this is going to be your run. So what I want to do is I want to get this on there, and because they're also asking like this, like we read, they're asking for the angle of elevation. So the rise will be 25 and the run will be 100, or some multiple of that. All right, it could be 250 and 1,000. It's the same equivalent fraction, but here, let's take this a step further. What is 25% or 25 out of 100? Isn't that 1/4? All right, we could also use 1 and 4. It would give us the same thing. So what I'd like to do is this. I want to try to solve and find the angle of elevation here. So let's think, where is 25? Where is 100? And as a result, which trig equation will we use? So we're going to use tangent. So that'll be tangent of theta, which we don't know, the angle of elevation, angle of incline. And then tangent is equal to opposite over hypotenuse. And we're right back to where we were. If you wanted to, we could actually just use 0.25, which is 25%, which is 25 over 100, and it is also 1/4. So in this case, let's show our couple steps here, right? We want to undo tangent, so we will take the inverse of 0.25 or 1/4 or 25 over 100. And what do we get here, ladies and gentlemen? I'm getting about 14.04 degrees. Nice job. In this example, we want to try this NJSLA practice question. It says, using the diagram below, the observer on the roof, which is this little dude up here, what did he do? He sighted the top of the tree at an angle of depression of 38 degrees. The same observer sights the bottom of the tree at an angle of depression of 59 degrees. If the observer is 100 feet away from the tree in the horizontal direction, then how tall is the tree? Okay, some things we need to kind of pick through here. So the easy part for me is the 100 feet away in the horizontal direction. Yes, we could have also put it down here, but I want it to be a part of my triangles. Now we have two triangles that are overlapped. All right, we have triangle ABC, and then we also have triangle ABD. All right, and now I want to use those because those are our right triangles. Now I have those drawn separately over here, so what I'm going to do is I'm going to get the 100 on each of them because they do share side AB. All right, now let's go back to the angles here because this is really important. So if you're observing or you're kind of looking out and, looking out horizontally, right? An angle of depression is how many degrees we look down in the horizontal, from the horizontal direction. So guys, think about this. In order for this observer to sight the top of the tree, okay, they're only looking down 38 degrees, okay? We're going to take the lesser of the two angle measures because you don't have to, you have to dip your chin down only 38 degrees to sight the top of the tree. Meanwhile, you would have to drop your chin lower and look further down to sight the bottom of the tree. So the angle of depression will be greater to see the bottom of the tree where this observer is standing from. So I want to take that information, I want to go get that on my graph, okay, or on my diagrams. So if I do that, I'm going to put my 38 degrees here, and I'm going to put my 59 degrees here. All right, so let's think about this. Now, we're not going to use this little sliver of a triangle, triangle ACD. All right, it's not a right triangle. We'll learn later on in this chapter how to deal with non-right triangles, but for right now, let's try to figure out how we're going to get this length of this tree or the height of this tree. So think about it. First and foremost, I think BD is too long, right? But in this triangle, we can actually find that length here, right? We'll just use trig to find the length. However, BC we could also determine, right? If you look right here, we could find BC as well. BC goes from here to here. So what I'd like to do is this, ready? Actually, I'll put those back. I'm going to use X as the length from B to D. I'll put that on my diagram. And I'm going to use Y as my length from B to C. Again, I'll put that on my diagram. How will we find the height of the tree once we obtain those two numbers? Well, we're going to take the full distance x, and we're going to subtract y, and that will leave us the height of the tree. All right, so let's go ahead and give that a shot. All right, so we are going to actually have very similar looking equations. I'm going to zoom in here and use red for triangle ABC. We have opposite, we have adjacent. I'm using tangent, and let's see, that's going to be tangent of 38 degrees equals y over 100. Ladies and gentlemen, what will you get for the value of y to the nearest hundredth? Well, we're going to solve this equation. We're going to end up multiplying 100 times the tangent of 38 degrees. There's my 3 steps, and that is approximately 78.13, and what was our label? It was feet. Okay. All right, so from B to C, it's a little over 78 feet. Now let's go down here and solve a very similar equation, but for x. All right, the only thing that's going to change here is going to be our angle of depression, right? It's going to be bigger. So guys, we have the same type of equation. We have tangent of 59 degrees now equals opposite over adjacent. So please solve this equation and let's see what you get. After multiplying by 100, we're going to get the tangent of 59 degrees is 166.43 feet. Now we're about to finish up the question. So like we said before, we're going to find the height of the tree by taking x minus y. So let's go ahead and substitute those values. What is the approximate height of the tree? I'm getting approximately 88.3 feet as the height of our tree. Nice job. Okay, everybody, last example. The angles of depression to the near and far banks of a river measure 49 and 11 degrees respectively. If the observer's eyes are 1.8 meters above the ground, then how wide is the river? Hint, use example 15, the one we just did, as a guide. All right, so guys, real quick, what we're going to do here is as soon as I read angle of depression, I'm going to draw our usual picture. So this is citing the far bank of the river. Now, I want you to think about this. This observer does not have to look down as far as he or she would to see the near bank. Plus, they even say the near and far banks of the river respectively, which means in order. Now, ready? I'm going to put my 11 degrees here, okay? And then they also tell us that the observer, to his eyes, or her eyes, are 1.8 meters. So I'm also going to put that over here, okay? So now, let's think. This is similar to the last example we just did because we can find that length. But if you notice, this observer is not standing right on the near bank of the river. So it's too much. That's going to be too long. All right? But let's keep going here. The observer also sights the near bank of the river at an angle of depression of 49 degrees. Okay? So I'm going to use blue here. Now he or she has to look further down. Okay? They're still 1.8 meters tall, but they have to look down now at 49 degrees. All right, so our diagram starts to overlap and get confusing here. So what I'd like to do is draw each triangle separately. Okay, now that I have drawn and labeled my triangles separately, I'm going to call the longer length from here to here A. But the length of A is too long, right? So we're going to have to remove that length there, which is going to be represented by B. Ladies and gentlemen, how will we find the width of the river? We're going to use A minus B. All right, so what I'd like to do is write two equations, but guys, they're going to be the same types of equations. What trig function will we use for both of these examples? Correct, we're going to use tangent, okay? So one more time, we're going to have tangent of 11 degrees equals 1.8 over A. On the other hand, we will have the tangent of 49 degrees equals 1.8 over B. In both of these cases, we will have the variable in the denominator, so therefore we are going to divide. So what I'd like you guys to do is please finish this up and tell me, what is the width of the river? Okay, after solving each equation, we get A is approximately 9.26, B is approximately 1.56, therefore the river is about 7.7 meters wide. Ladies and gentlemen, I hope these videos helped. I would like for you to leave me some feedback or give me some specific questions. So thank you very much.